Hey, this is Florin, and today I want to show you one of the really nice new features in EvoluteTools PRO, which is the support for creases or sharp features. And this allows you to optimize meshes over reference surfaces that have some discontinuities like cutouts or steps or any kind of sharp feature. For this I will use this flying carpet model, which you can download from our website. It's actually a pretty smooth mesh, and I will want to reverse engineer it into a NURBS patch and do a bit of modeling to get some sharp features over it. And for the reverse engineering, I will use EvoluteTools PRO as well. You can actually use the light version. I will just optimize a really plain quad mesh over it, and then I will use that mesh to build a NURBS patch over it. Alright, so I'll just use a bit of local subdivision. Fix some vertices so they just stay there. Declare some vertices as corners so that breaks the fairness around the corners. Do some global subdivision. Get a pretty nice density. Set my reference surface and just put all the optimization importances to default. And then look at them again and just put a bit of fairness curvature here. Alright, so I'll just optimize this thing now. So the main task for this was to get this subdivided mesh really close to that triangulated one, which I can delete now, and I can build a NURBS patch over this one now. So I'll extract the polylines out of this thing, delete the mesh, and I'll just use this wireframe network to build a NURBS patch. I'll just use the patch command for this, and now I have a really nice smooth NURBS surface. It's smooth, but I'll start to chop it off to get some sharp features. Alright, so I'll draw up some curves over this thing, something like this. And I'll split the surface with these two curves. Just delete everything which I don't need. And I'll create a pretty big step in the surface here, like a really sharp thingy. I'll just smooth these things a bit closer to each other. And just create a NURBS patch in between here with a loft, really simple loft. Join everything together. Put it in my reference layer and set it as a reference because the previous reference we just deleted. So I'll set this thing as a reference. That's done, and I'll start again with just creating a coarse mesh and do a bit of optimization. I'll start with a single quad face. Again, do a bit of local subdivision, fix some vertices, and declare some vertices as corners. Alright, and now let's just get it denser, do some global subdivision. This should be quite okay. Alright, the optimization importances pretty much default, and a bit of fairness curvature. I can use that for the moment. I'll just select the mesh and optimize it a bit, and it works. Alright, what we do notice is that here at the sharp step the mesh still tries to be smooth because we didn't flag anything for creases yet. And in order to make that crease work there, so that the optimizer just takes it into account and breaks fairness there, we have to do three things. Alright, so first of all, we have to break the fairness there. And we do that by defining those long polylines along the crease as edge features. So we have a command for this. It's called etSetEdgeFeature. And let's check out the selection modes. You can select edges one by one, a whole polyline, and you also have an angle auto detect option. I'll just use polyline for this one. I'll just pick this one and this one. Alright, so now they are set as features, 64 edges set as features. If I invoke the command again, it will just show me what's selected. Alright, so this was the first thing, the first task, just breaking the fairness there. The second task is actually to declare those vertices along the creases as additional curve points. So I'll just select those vertices, use the selection tools, and this one, and I'll just define them as additional curve points. set vertex curve point. Alright, that's done. So I have one thing remaining now. Now, basically, I have to define the crease in the actual NURBS polysurface as an additional reference. So to do that, I'll just duplicate these edges, these sharp edges here, and just define them as an additional reference. Okay, this is done. So hopefully everything should be working out quite nicely now. Let's pick our mesh and do a bit of optimization. Okay, so things just pop nicely into position. I have a bit of an issue here. There's a vertex that just doesn't want to snap to the correct border, and I can just take care of it, increase the fairness a bit, and it should go exactly where it should be. Alright, I'll just hide my reference surface so we can have a better look at this thing. So basically this mesh now is just it's a single mesh, it's connected, it's welded, but we can optimize it over this pretty steep feature in the reference surface with the help of the crease support. Alright, so thanks for watching.